Okay, we're going to look at a second spin-off, a second corollary for Euler's theorem. Now remember that Euler's theorem in connected planar graphs is simply that vertices minus edges plus faces are equal to 2. Now the second spin-off is saying that 2v minus 4 is always greater than or equal to the number of edges. So first of all, I'm going to think about a tree, and I'm not going to draw this one out, but 2 vertices minus 4. Now in a tree, the number of edges is v minus 1. So when we rearrange this, we have v is greater than or equal to 3. So we know that this is only going to work if v is greater than or equal to 3. Actually, v has to be greater than or equal to 4 for this to work, and I'll show you why. It's because of this thing here with no triangle. So if we did make v3, we'd have our 3 graph here, and its connected planar graph like this. That makes a triangle, so we're not allowed to have that. So we're going to start with v4, so we're going to put an extra dot in there and make it v4, and let's just join those up. Now I can join that to there, and I can join that to there, this one up, and I can join this one up. So we don't want a true, we're looking at a connected graph. I'm not going to join the middle ones together, because if I do, I have a triangle, obviously. And I'm not going to join this one with this one, because that actually makes 1, 2, 3 edges. It's the equivalent of a triangle. There is another, I could do one with F5, just to show you what, graph 5, G5 looks like. So I could have G5. Clearly we can join all of these together and make one face in the middle. I can't make a triangle up, but what I could do is I could join this dot all the way around to this dot, and this isn't a triangle because it's 1, 2, 3, 4 different faces. So let's just write some of these in. If we've got this one, we've got one face, and this one here has got 2 faces, 1, 2, and the third one outside. Now what I can see from this is clearly that the edges are always greater than or equal to 4f. Every face that I've got makes at least 4 edges. But edges share a face, so I'm going to divide that by 2. When we rearrange this, we're going to have E and E over 2 is greater than 1 face. Sorry, it's just getting my algebra right there. So this is the rearrangement. Now I'm going to go up to Euler's theorem and put this in. And we see that V minus E. Now let's replace the face here with E over 2, and because of this one being greater than or equal to, I'm going to replace equal with greater than or equal to 2. Multiply everything by 2. 2v minus 2e plus an e, and you can see that our formula is going to come together here. This is going to give me 4. When I rearrange this, this gives me negative e, so I add that to both sides, take away this 4 from both sides, so I get 2v minus 4. And this is my second corollary from Euler's original connected planar graph theory.